Greetings, everybody. This is going to be a different training. Different in a positive way. Why? Because we're going to make a relationship between all the AI definitions and theoretical information that we have just studied and our field, the computer networking field. So what is it for us? What's in it for us? I mean, I want to see some kind of use cases to make sense. I want to see how AI can be deployed in the computer networking field and in the security field as well. So get ready and let's get going. It all starts with network analytics. But hey, what is analytics to begin with? Analytics is like having a super sleuth for your data, uncovering insights and making sense of numbers. But what about AI-driven analytics? Well, it's like giving Sherlock Holmes superpowers. AI dives into data, finding patterns no one even knew to look for, and all without a single line of code. In the world of predictive analytics, AI becomes a fortune teller, predicting network hiccups before they even happen. By comparing real-time data to past trends, it can tell when something is about to go wrong, letting you fix issues before they happen, before any disaster can happen. Then there is predictive maintenance, where AI acts like a high-tech mechanic. It keeps an eye on equipment, spotting wear and tear before things can break down. Think of it like catching a flat tire before it ruins your road trip. So tell me more about the process of AI-driven analytics. Well, it has several steps. First of all, the data is being collected from network devices and sensors, capturing performance metrics, usage patterns, and environmental data. This data is then processed through cleaning and transformation to ensure accuracy, as flawed data can lead to incorrect predictions. The data is either segregated for easier future use or aggregated for deeper insights, enabling machine learning models to recognize patterns in normal operations and failure. Once processed, the data is then stored to continuously refine and update the models as the system evolves. As new features or usage patterns emerge, the models adapt. Insights from the processed data are then presented through some kind of dashboard or visual tools, making complex information more accessible. And then finally, the network administrator can take an action based on these insights, responding to patterns that suggest potential issues or optimizations. Now, how can AI optimize my network? Okay, let's imagine this. Imagine you're in a busy highway and to just add insult to injury, let's just, face some rush hour chaos. And that's what modern network suffers from all the time. But wait a second. There is the dream team, Cisco Stealth Watch, App Dynamics, and maybe even Thousand Eyes, the ultimate traffic cops. Okay, these tools powered by dynamic routing abilities will make sure your network does not end up in gridlock, rerouting data like GPS, avoiding traffic jam. Okay, but the real magic is actually going to happen when AI is being added to the mix. That's just App Dynamics, Thousand Eyes, and Cisco Stealth Watch without AI, but AI is there. So what's AI going to do? Well, your network is going to be constantly learning and predicting and adapting to ensure network reliability. Yeah, AI not only prevents bottlenecks by intelligently rerouting traffic, but also it keeps services humming to, no matter how heavy the load is. This means real-time adjustment that improves capacity planning, so you never have to worry about running out of road. Even better, AI does not just react, it predicts. Using those different Cisco tools, your network becomes a fortune teller, spotting traffic spikes during major events like, for example, product launches. With this foresight, you can ramp up resources ahead of time, ensuring no one hits a bottleneck or a roadblock and your network stays smooth and fast all the time. The result? Enhanced network performance that keeps everything running smoothly in an automated fashion. Now let's come to one of my favorite use cases, which is the network automation and self-healing fabric. What's that? We can actually use AI into our day-to-day network operations. Specifically, I can give you a name here, the Cisco Catalyst Center, which is formerly known as the Cisco DNA Center. What does it do? Well, the Cisco DNA Center is actually made of different components. One of its components, something which is called the NDP, the Network Data Platform. What's with the NDP? The NDP is the brain responsible for the telemetry and fixing of issues. What does it do exactly? Well, the DNA Center or the Catalyst Center is actually connected to the network infrastructure devices. It keeps on continuously collecting information to analyze this information. Network analytics is always happening. So if there is any kind of deviation from standard, well, it's going to consult its database. It's going to just compare the metrics, compare all the numbers. And if it deviates from standard, it's going to suggest a bunch of actions for you. How's that possible? Because, hey, with Cisco AI Cloud, the Catalyst Center is always communicating with Cisco AI Cloud to make sure that it's actually correlating the data to the right inputs or to the right information that the network should follow. So what happens? It's going to give you the list of recommendation actions. And if you happen to be there, you want to choose from these actions, well, be my guest. If not, then it can actually heal the network for you. It can implement those best scenarios and the actions for you to make sure that your network is performing best. It's a closed loop cycle. That's why we call this a self-healing network. Problem happens, don't worry. It's going to take care of it for you. Now tell me something. Can AI help in the field of cybersecurity? I'm concerned. Oh, guess what? I have good news for you. AI and machine learning are transforming cybersecurity as well, especially in threat detection, incident response, and predictive risk management. By analyzing network data, AI can help in detecting different kinds of threats. For example, brute force attacks, malware, and phishing attempts in real time. Tools like Cisco Stealth Watch and Cisco Secure Endpoint Analytics leverage machine learning to monitor network behavior and identify vulnerabilities across various attack surfaces. When it comes to incident response, first of all, AI automates the process, enabling rapid mitigation of threats by responding to breaches and security alerts quickly and efficiently. In cybersecurity, risk is the potential for loss or exposure, often caused by vulnerabilities or misconfiguration. Predictive risk management helps identify these risks before incidents can happen by analyzing the data, as I said, from system operations. AI actually plays a key role by comparing system data with historical patterns. Prioritizing risk based on potential harm. Tools like SNCC from Deep Code AI perform code analysis to detect vulnerabilities such as SQL injection and XSS, reducing risks in applications. In network security, Cisco Network Analytics with the Cisco Catalyst Center, for example, these different tools use AI to assess network exposure and vulnerabilities, analyzing root cause, not just solving the problem, analyzing the root cause and take corrective actions to prevent future issues. Summary time. AI has different use cases in the field of networking. First, AI-driven analytics, where AI finds hidden data patterns, predicts issues, and performs predictive maintenance to prevent failure, where the analytic process itself is formed of different steps. Data is collected, cleaned, processed, and stored for model updates with insights guiding network improvement. We have use cases like network optimizations, where AI tools predict and reroute traffic, boosting network performance and capacity planning. Whereas when it comes to automation and self-healing, the AI automates the troubleshooting and fixes network issues with human oversight for critical decisions. And let's not forget cybersecurity, where AI detects malware, phishing, and vulnerabilities, automating risk management and incident response. I hope that this has been informative, and I'd like to thank you for viewing.